This is an interesting article that came out in a journal that mostly originates in China, even though it's published with international collaborations. A couple of authors are well regarded. I know them personally, so I'm going to include this because it's very much relevant to the unusually strong 26-27 El Nino that's growing right now. This fake super El Nino title I'm not so sure about, but extreme spring Pacific annular warming elevates the 26-27 El Nino. What is this annular warming? How unusual is it? Strong sea surface temperature anomalies were observed in the western, northeastern, and the southeastern tropical Pacific in spring 2026, forming a rare and extreme annular warming pattern in the tropical Pacific over the past 40 years, the most unusual over 40 years. Meanwhile, the upper ocean heat content in the equatorial Pacific has turned positive, seemingly ready to boost an El Nino toward the end of 2026. So discharge has happened. Using a state-of-the-art climate prediction system, we show that if the current heat content buildup leads to a moderate 2026-27 El Nino, the extreme spring annular warming pattern is highly likely to elevate it to a super El Nino. There is that terminology again, completely made up, not scientific. While the impact of the annular warming is insensitive to initial conditions in the model, interbasin remote forcing and high-frequency perturbations may introduce uncertainty into our prediction. 23-24 was related to interbasin remote forcing. So far, the coupling is very strong within the tropical Pacific for the 26-27 El Nino, with the westerly wind bursts starting very early on in the year, even December of 25 at the end of the last La Nina. Okay, so tropical Pacific Ocean SST and heat content anomalies by February 26 were already showing this so-called annular warming pattern. Warming over here, northeast, southeast, and you can generally draw a ring around it with the remnants of a La Nina still there. There were some wind anomalies. These are still easterly anomalies, so upwelling is still maintained. D20 anomalies, you can see that they were negative here, which means thermocline had shoaled, which is approximately consistent with the warming. They are deeper here, which is approximately consistent with accumulation of warm waters at the recharge phase. And then you have also deeper thermoclines associated with the other regions that are of importance. SST anomaly annular pattern intensity, same signs and different signs, so they are basically defining it as an index. Medium, so wind stress are shown. Medium purple and blue, violet and magenta areas denote western tropical Pacific, northeast and southeast tropical Pacific respectively. Text indicates the ranking of the area averaged February in El Nino years since 1980, so that's February warming, and in 2026, which is out here. Text indicates the corresponding ranking. Same and different signs. There are so first, second, and second in terms of the ranking for 2026. B annular pattern intensity in February of El Nino years since 1980 and in 2026. Text indicates the corresponding ranking. I'm going to lose track of the text here. Red and green bars denote SST anomalies in these three areas with and without the same signs respectively. C is same as A, but for thermocline anomalies, and D is of course the heat content anomaly. So heat content anomalies are warm water volume is not that unusual, but the same sign here and different signs here. This one is the strongest same sign annular signature we have seen in 40 years. Okay, so they use the models obviously to include and suppress the relative anomalies to produce total predictions to say why it will get stronger. Okay, influence from remote forcing and high frequency perturbations. To assess the influence of the record-breaking annular warming in February 26 on the possible arrival of the 26-27 El Nino, we need to isolate the impacts of remote forcing, high frequency perturbations, and HC buildup, heat content buildup. First, we conduct experiment G, which is a forecast experiment starting from 2026 March 1. All ensemble members from experiment G predict an El Nino that peaks in December 26, a phenomenon known as phase locking. The average for December of 26 and January-February of 27 is 2.61 degrees C in this prediction, meeting the criteria for a super El Nino, which is made up, as I said, and is close to most predictions from other popular ENSO prediction systems initialized in February or March of 2026. There are other details in this section that I'm going to skip and jump to the impact of annular warming on 26-27 El Nino. The prediction from experiment TP minus LP indicates that without remote forcing and high-frequency perturbations, the tropical Pacific will experience a super El Nino towards the end of 2026, and the results are insensitive to the initial conditions used in the model. To assess the impact of the annular warming in the spring 2026 on this possible upcoming event, it's desirable to isolate the influence of heat content buildup. Given that the response of large-scale atmospheric circulation to SST anomalies can be established in less than 2 weeks, we set up an experiment termed experiment HC, that's my screen looking dirty there. Sorry about that, it won't come off, but oops. HC, in which SSTs in the tropical Pacific are restored to model climatology in 2026. Other settings are identical in the other experiment TP minus TPLP. In doing so, we effectively remove the impact of tropical Pacific SST anomalies in March 2026 from the prediction system, allowing the outputs to represent the deterministic low-frequency atmosphere-ocean coupling induced by the heat content buildup or the recharge process. Essentially, they are doing experiments to isolate the role of the annular warming. They say is the most unique in the 40-year record they look at. So here we are going from January of 2025 into April of 26, where the experiments were done. We were in a La Nina with some low warm anomalies in the low deep anomalies in the thermocline, corresponding to those warm SST anomalies, and then La Nina disappeared. First, a westerly wind burst appeared and a Kelvin wave, downwelling Kelvin wave, propagated eastward, and then you had other wind anomalies into March, April, which have now grown way past the dateline into the eastern Pacific. Associated with them, La Nina anomaly almost disappearing, reappearing, and then disappearing into February, March of 2026. And there are corresponding zonal wind anomalies, easterly anomalies, and westerly anomalies and easterly anomalies. Remember, eastward is positive and westward is negative. So these are easterly anomalies, westerly anomalies and easterly anomalies. And here are the ones that kicked off the beginning of the signatures in terms of discharge and so on. So I won't go into the details, but their various experiments show how the tropical Pacific and the original global experiment end up predicting the Nino 3 anomalies, and you can see the differences in them. So remember that the annular warming is claimed to have happened in early part of the year, and then the predictions are for the later part of the year. So this is for February 2026, which presumably affected wind anomalies and the coupled feedbacks in the following months. Is that really convincing? You have to decide for yourself. I wanted to include it basically to show, and obviously I'm being very lazy about the detailed experiments because they add the Northeast tropical Pacific influence, Southeast tropical Pacific influence, heat content plus the Western tropical Pacific influence. So the standard discharge El Nino evolution with high frequency perturbations versus contributions from the Northeast tropical Pacific and Southeast tropical Pacific warmings. And the idea is that adding the annular warming from the Northeast and Southeast tropical Pacific add a lot to the amplitude. Okay, so here is how they see it. Sorry for being brief, but it's a short paper. You can go read it. Schematic illustrating the mechanisms through which the annular warming pattern influences the 26-27 El Nino. Red shading denotes the annular warming pattern that we mentioned here, maybe a little bit exaggerated, oops, but nonetheless. Black and green solid arrows denote surface winds and currents. So here is currents, here are the westerly wind bursts, here are the weakening trade signatures associated with the eastern and northeastern, southeastern tropical Pacific warmings. The white dashed curve denotes the equatorial thermocline, which obviously slopes eastward, but once the discharge starts, it begins to flatten, and downwelling Kelvin waves because of that, and the eastward push of the warm pool, shifting deep convection and other ITCZ signatures all begin to act towards setting up the El Nino. Dashed arrows here, future change in the predictions, and contours denote surface wind and SST anomalies in the near future respectively, so their predictions. Okay, let's jump to the discussion. It should be borne in mind that it is currently not easy to make an accurate prediction of the forthcoming 26-27 El Nino when they did it in March with March initial conditions, if at all it occurs, because you could always have a collapse and so-called aborted El Nino. We have to be careful using that word, but this concern stems from the fact that in most prediction systems, El Nino is primarily determined by the state of the heat content buildup. However, a majority of El Ninos over the past 2 decades have shown that heat content buildup is insufficient to provide reliable short-term predictions. The failure of forecasts of 2014-15 and 15-16 El Ninos based on spring heat content buildup in climate models has provided profound lessons. Models catch on to these anomalies and then become too confident in predicting El Ninos for the following months and seasons. But unless you have these high frequency perturbations, these may not necessarily grow into a full-blown El Nino, and we have seen too many failures of this kind recently. Relatively low short-term prediction skills for tropical Indian Ocean and Atlantic Oceans their SSTs also add uncertainty to El Nino forecasting. We saw 23-24 was kicked off by weakening of the Walker circulation and trade winds by the warming in the Atlantic and Indian Oceans, so it wasn't coupled strongly in the tropical Pacific. Moreover, extreme HFPs in the TP during spring and early summer are by definition unpredictable in climate models because they are more synoptic features, not low frequency climate features. In summary, the analyses presented here reveal that the tropical Pacific exhibits an unusual annual warming pattern in spring 2026, which ranks as the largest over the past 40 years and could significantly intensify warm SST anomalies in the eastern central equatorial Pacific towards the end of 2026. Obviously, we are headed that way unless something completely surprising happens to damp it. If the current heat content buildup leads to moderate El Nino, the annular warming in the TP should make it a super one. El Nino never ceases to surprise us, and we can only anticipate its mysterious behavior based on known processes within current models and the boundaries of our understanding at hand. That's the end of this paper, but essentially, is one sample enough? Well, to the extent that this model is being used to produce the predictions which get stronger with these signatures, we can say that the model which does El Nino reasonably and predictions reasonably is giving weight to these and associated wind anomalies. But Obviously, models have biases. They don't do cloud response very well. They don't do westerly wind bursts and so on. So considering that the prediction has evolved to be basically right, we have to see whether this ring pattern, annular pattern itself is related to global warming. Is it something unusual? Is it just a complete random internal variability? And so on. These are all critical questions which are, of course, dependent on having more samples. Okay, let's leave this here. Important component of the circus of Super El Nino we are going through, so I'm going to include it here. Okay.